Welcome to this CNaaS Infoshare. My name is Maria Isabel Gandia. I work for CSUC and I'm working for the GM43 project on Wordpacket 6 on behalf of Rediris. I'm chairing this session today with the help of SUNET and FUNET and UNINETT we're going to do. And Ivana and Tim are also co-chairing this session in case there is anything. They are also chairing the session. Okay, so thanks for joining. As you know, the number of NRENs offering campus network management services is increasing. Sometimes it's the government who is mandating or asking them to, for instance, manage the schools networks. Sometimes it's the institutions, like in the 3 examples we will have today, that are asking the NREN to offer these services. And the GÉANT project in Wordpacket 6 have been working on CNaaS with the NRENs, creating a service definition template to be adapted to each case and also mapping some architectures. But the institutions are facing some problems that didn't face before with campus network management services. They mean they need more people, they have more work, including paperwork, and they need more automation to offer these services. This is our agenda for today. We will start with David Heath from SUNET, who will explain their experiences in offering CNaaS services. Then we will have Asko Hakala from FUNET that has been offering some campus services for years, but that now are evolving. And finally, Vidar Faltinson and Morten Breckable from UNINETT will explain their experiences with 2 new customers and focusing on their aggregated alert system. We will have some time at the end of each presentation for questions and answers, and a final discussion with the speakers where you can also ask questions and share your ideas. Having said that, let's start with David from SUNET. David Heath is the product coordinator for SUNET's efforts in building and maintaining campus network as a service and also their security center. So David, I stop sharing and you can share your screen.
Yes, thank you. Hello all. So let's see here. There it is. Yes, so SUNET has been doing this project and service for 2 years now. We started it in the fall of 2018, and we want to extend the network that NREN provides. And we also want to share the experiences with the staff and keep them. So we want to do this in the way of automating everything more or less with the easier replacement of equipment without having to have a senior staff always on site. And our first production campus was mdh.se, and we have several new interests and signed a contract with others now. So we are actually getting this rolling right now. And we are doing this transparently. So we, at the end of the presentation, I will share quite a lot of links where you can get access to all the source code. And we want to collaborate and get thoughts on how we can improve this together within the European community. And as I said, this is a challenge locally for the campuses. They have aging staff, they have trouble keeping them, and they also needs to get experience in these advanced network environments. So it's troublesome for the smaller mid-sized ones to fill the ranks, and it's also difficult in other areas. But we don't want to get anyone fired here. We want to do this together with them. So we try to make these people grow. They get new colleagues, they get people backing them up when they are on vacation, sick days, and attending like webinars like this, for instance. And we also give them exposure to the enterprise grade equipment and automation that they previously perhaps didn't have. One of the reasons that we are doing this more with programmers than pure network engineers is that the things are going more software defined. It's not really the case where you switch the dip switches on the motherboard anymore. Everything is software defined, and that includes how we handle firewalls and everything. including the data center. We focus primarily on the delivery on the access switches for the campus on the like offices, but I think in the next iteration we will work much closer with the data centers as well. Another trend that needs these big network upgrades is that it is quite a lot less local compute nowadays. It's much more centralized services and cloud services or remote services of different areas. We did a reference architecture together with the technicians and engineers, utilizing the best practices in a leaf spine architecture. So this is our rough helicopter view of the architecture. I have some slides later on quite detailed that we can share as well. Everything is redundant except the access port locally on for the offices. But Wi-Fi, we try to have coverage over areas. Another thing that I want to mention is that we do some joint engineering and sharing between the Nordic countries, specifically Norway and Sweden are doing this. We are making use of their nav that Morten and Vidar will show later today with Argus. And we also share the code for the network management system. So we have open dialogue on this, on how we can do this together. Some of the business advantages for the local campuses were that we standardize the things. We have higher security and repeatable quality, and that is the thing that the IT directors like. We don't necessarily say that we will do it for lower cost, but in the end, we actually saved quite a lot of money due to our procurement that got really good pricing. And we don't lock the local staff and resources. So this development and integrations is done in parallel with their normal projects and lives. We just support them. Yes, you can read the slides. They are shared. I think this is only a 20-minute talk, so there are some technology advantages, definitely. As I said, we do the campus network as a service network management system open source. So everything is documented publicly on GitHub. The NMS system itself is a hybrid infrastructure as code with an API that supports automation. We deploy them through separate Docker containers. And this overview shows a bit of the components that are shared, and we are happy to do another webinar or something to go much more in detail on this architecture. The service delivery is shared, so it's a collaborative service between the local university and our contracts and the supplier, and everything is integrated process-wise and support-wise. So the universities actually have SUNET accounts, so they can file support errands and escalate together with our NOC. Some of the different models that we have seen, we try to do it as a full service, but in the end, everyone wanted different options. So for the first one, we actually do the full service, but for another university, we talk about just doing the wireless. Some just have bought quite a lot of equipment, so they just want the procurement and support option. Some we are doing extensions, NOC monitoring. And we also have local systems that they want to change, so we do some development work as well. One important issue that is that local staff handles the physical and end user issues, so they need to have tickets filed locally before they get to access. This is just some screens of our campus that we built together with MDH. It's a new building, so it was totally greenfield, which was fairly good for us that we can do this together with them to really configure everything as wanted and needed from the beginning, not having to have so much history. And our hardware design is based on Arista, mostly for everything. We have some Cisco gear previously, and the AV systems are separate from this as well. We do centralized logging to us over proxy services. We're using mostly open source components, but as the security center grows, I hope that we can really integrate the radius logs and the syslog events from all components to get a much better aggregated view. We also support command line for the API calls and the config management, but hopefully we will have the web GUI much more supporting of all common cases. But right now we work with templates. So this is just a device diff that we wanted to show that everything is shown before committed. So we do dry runs and tests, and then it gets deployed. And we have some demos on how this works. And today we have quite short time to show everything how it works. So I give some links at the end of the presentation. We also document everything on the cabling and switches where it's connected to follow up on labels now that we have a new campus. So we did a rehaul of the SUNET knock-look integration there. So everything should be updated. Yeah, and the Wi-Fi, it's since it was a green field and we got so good prices, we have quite good coverage. So the students and teachers can move freely with good coverage, and we can also lose a couple of APs without them losing connectivity. Even the elevators between floors are fixed now. To support the tests, we set up a lab in Stockholm. Unfortunately, the procurement took quite long time, so we actually did it. We did it together with MDH to get things working together with them. So it was fixing forward, if you say it like that. And we share this lab with the other universities to test configurations and automation. So hopefully we will continue this this concept with others, and we can test each firmware upgrade before anyone disrupts services. One of the big things for us was that we did the procurement where we wanted to handle the support issues ourselves and be very close to the distributor locally. So we got Arista up for that, so that we actually got like the shipping container prices for the equipment with just a couple of percent added from the distributor. And once you go up in volume on devices, these changes really shows if they add 20-30%, which is fairly normal per device, and then they have the support for 13% per year on ongoing. That definitely could be the difference between keeping or getting more staff to support this. So I think we get both better automation, better support, and lower price on the total, including the equipment, than if we just have done a regular deal with a distributor. And we also subsidize the prices right now. So the first couple of customers we actually lose money on, since we have this thought that the NRENs need to change our model on how we do the core network. So as we change the equipment and we roll out to the more campuses, we will either provide a much better service or we can lower the prices. But right now we got some funding from the Research Council to make this technology shift. So we don't bill the other universities that are not part of the service yet. So it's a cost transparent model, and hopefully during this and next year we break even. This is just the slide to show that the NOC itself is more focused on the events and the scaling of systems. So it really didn't change so much. I think this will show over time, like when the equipment is 4 years old or something, when it's either start to fall apart or if it's time to replace, then we need to address our central NOC, how the personnel, how much stress it is to have 10,000 more devices to monitor. This is just an estimate to talk about. And a short review of our timeline. Last year we did the procurement. We also ordered the test equipment during late last year and tested the automation. And so we started in January with the actual initial testing production there. So we finalized the testing in the spring, and we had the contract up and running. Now in September, we did a delivery report. We had well over 99.9 availability for everything, including one radius instance going down that disrupted it a bit. And going forward now, we do a new project, and now it's official. It's Stockholm University, one of our biggest networks. That is our new campus that we are working in parallel with. This is some tips for you to validate. If you do this, you need to think about how the aggregate log and alert views are handled. UNINETT spotted it early as well, so they started the project that we will hear later on. And also the escalation inter-organization-wise of support requests. Who files it, who owns it, how is the process handled? And also we did almost a year of development of all these functions and functionality that we talked about, but it was not really tested in the real world. But it went fairly good. But it was a lot of guesswork on which functionality must be there from the beginning. Another is the firmware upgrades, but I think our central lab will handle these configuration differences. And also how to keep track on these special devices locally. If you do have a central configuration, if you swap and change equipment, how to keep track on these specific changes. We try to do everything centrally, but as everyone knows, something's happen locally anyways. These are some of the components that we have in the ecosystem, if you call it that. With NMS is the central part, but we also have quite a lot of backup interfacing systems and that do the work. So here is some of the links of things I didn't have the time to cover today. We also have some live demos that my colleague Johan has made that are fairly good to show a bit of how it works in practical terms. Yeah, so are there any short questions now that needs to be addressed, or you want any specific ones?
We have a question from Peter. Peter, do you want to ask the question directly, or do you prefer?
Yeah, I'm also willing to ask it. So I was wondering, are you also getting questions about providing standardized campus services like DNS, DHCP, LDAP, that type of stuff? And if so, are you going to add them as modules to CNaaS?
Yes, we could possibly do that, but the ownership and the administration of the data itself is always owned locally. So like the radio servers, for instance, we have done some integrations together with them to get the AD integrations. We also, quite a lot of universities are using Infoblox today for the IPAM and address management, firewall ACLs and different other adjacent areas. I think that we will do this in combination with them, but I think eduroam is probably the one that people talk the most about, to have us having that handled centrally.
Yeah.
Yeah.
And are you going to be adding that, or is that something that you're still trying to figure out what's handy?
Yeah, I don't think it will be a strict part of the campus network as a service component, but it will be a separate agreement for those that are struggling with either the technology changes or keeping up with the technology, or just doesn't have the staff to support it locally.
Yeah. Okay, thank you.
Yeah, thanks.
Thank you, David. Then we have a question from Franz Panken. If you want to ask the question directly, Franz. Or if not, no worries, I ask it. He's asking, does SUNET install and configure the equipment? This is attaching access points to the ceiling, for instance.
No, pretty much every physical aspect is handled locally, but in some cases we work together with them to fix some things. But in the contract, it is handled at the local level or by a contractor that does it.
Okay, thank you.
Yeah, in the MDH case, it was contractors who did all the access points, but the racking of the switches and routers are handled by the staff.
Okay, and so James Blessing, I don't know if he wants to show up.
Yeah, just a quick one is how many staff did it take, or full-time equivalent staff did it take to do all this?
We have 2 developers working full-time with this, and then it's the networking unit, which I'm a part of, that also handles all the regular stuff. So I says, apart from the development work that was like a precursor to everything, it's less than a FTE to keep it rolling and doing it. But the deployment took quite a lot of time since it was the first one that we did on the MDH. Now with Stockholm University, we think that we have documented all the dependencies and the script like on how to do it. So we hope to do it in less than 1 or 2 man-month to deploy the NMS and integration with radios, and also including it to the NOC monitoring.
Thank you, David. And then we have Jeremy Sharp.
Hi there.
Hi there.
Hi. Yeah, I wondered whether the service extends out to university student accommodation. And a second question, if I may, as well, is do you provide a 24-hour manned operations desk as well?
Yes, so with the accommodation, do you mean like the building houses that are connected, like student housing?
That's correct. Yeah, the student halls of residence.
No, those are in Sweden. There's been a change since we have big municipality area networks that are connecting through the ones that own the building. So it's quite a big trend that universities it's uncommon that the universities themselves operate those networks today. Yeah, and the second question was.
Yes, sorry, David, about 24/7.
Yes, our
yeah.
NOC is operated 24/7, but during the nighttime it's on call, pager duty on critical events. So we don't have staff during the night like eyes on the screen, so it's triggered alert.
Okay, thank you.
Yeah, and the local campus itself, it's one of the reasons the MDH got the contract, or wanted to do the contract, was that it was one guy, Jonas, who does everything. And it's only half of his time because he does quite a lot of more things. So we have a dialogue with them if it's physical changes and stuff, and that usually can take place before people wake up. So it's like virtually handled, but actually it's like pre-office hours a bit.
Okay, thank you very much, David and Jeremy. And one last question. Peter de Boer, you want to ask a question? If not, I can read it. Do you also have service integration between SUNET and the customer? For instance, a layer 2 serverized that runs into their network?
No, switching between VLANs and services that are provided they do the change request locally. We have thoughts about doing a self-service portal for network services as well, but I think it's an area that will grow over time.
Okay, thank you very much. Maybe we can keep more questions for the end discussion, because we are maybe running out of time. Thank you very much, David. Thanks for all the questions you have done also for the audience. Our next speaker is Asko Hakala. Asko is working in CSC, in FUNET Networks Group, especially in FUNET Campus Networks and FUNET Core Network. So Asko, you can share your screen now.
Okay, hi. So my name is Asko Hakala. I work with FUNET Campus Service and also with FUNET Core Networks, as Maria said. So the background for this service is that we used to have a service called FUNET Router Service that has mainly been used for CPE routers to connect to a FUNET network, and it was already started in 2012, and we currently have 12 customers there with 31 routers, and we are these older Juniper MX models, and it means that we have very non-standard configurations in these ones, and the devices themselves, they are pretty old and so on, and so they are pretty hard to maintain and do the configuration changes because everything is manual. And the new service is called FUNET Campus Service, and it was launched last year, and we have a 3-person virtual team doing this, but we also work everybody with FUNET Core Networks as well, so we are not full-time working with this campus, but quite a lot of time goes for this campus part. And here we have as routers, we have normally we use Juniper MX 204, but in some bigger cases we use also MX 10,000, and then we have Juniper QFX switches in some special cases, but usually as switches we use Huawei S-series 5700 and 6700. And currently we have 11 customers, and with 19 routers, 10 Juniper switches and 37 Huawei switches. So it means that we have been running this service about 1.5 years, and we have about the same amount of customers in this new service than the old one, and we have a double of devices in this new service. And now I will show you some typical use cases we are having. So this is the most common one. We use these campus routers as CPEs. This was also a typical case in the old service as well. And the reason for that is that we have a lot of other services in FUNET, so there is not just the internet over a FUNET network. There are L3 VPNs, L2 VPNs, access to some CSC's own cloud services and so on. So many customers want to us take care of all that routing part, and so we offer these CPEs. And now with these new routers, we can offer uplinks up to 100 gigs. And usually we aim to have these redundant connections, so there is a router pair. But now when we are having these switches, there are a lot of smaller FUNET members, like some research institutes and those who just want to have some switch taking care of these multiple connections. So we are offering those, and we have now quite many small customers who are having this just one switch connecting them to the FUNET network. And then we have our use cases that we have is this, that we offer a whole customer's own core, so it connects all the customers' campuses and goes all the way down to the aggregation level. And in these cases, we use QFX instead of Huawei as a switch because we have these Ansible automation tools developed for our own FUNET core network, and they support Juniper, so it's easier to use QFX in these more complex cases. And one issue is with these campus networks that there are much more L2 features in use, like MLAG and things like that, what we are not using in our own core network. So it means that we have to do quite a lot of development for this QFX automation templates, because there were features that we are not using elsewhere except in campus networks. And for these big networks, we also offer a possibility to have a share management with the customer. And one case that has becoming quite common now in Finland, that there is this universities, they are merging and they can have campuses in different geographical locations. So we connect them to a single network over FUNET core. So there will be 2 campus installations in those university locations, and then there will be layer 2 VPN point-to-point links over FUNET core. So for a customer, it looks like they are having just one single network, and they can have one AS. They can have 3 IP addresses. So if they want to use something like NSX, they can have backup service in the other campus and so on. So they have free addressing, and that's been quite popular now. And the problem there is that if they had 2 separate ASs beforehand, so migration itself needs quite a lot of design and planning, and that's where FUNET can help them a lot, these customers a lot, because we have some expertise in these routing matters. And then we have one pilot case so that we have gone all the way down to the access level. So it was one customer that has one new campus site, and they wanted us to build a switching network from scratch. So, but this is done in those Huawei switches where we don't have these very good automation tools yet. So it means that we design it as simple as possible. So we use switch stacking for this aggregation part, and so the network itself looks very simple, because everything looks just like one trunk, even if it's redundant. And so we have done this, and also we are not offering any services. All the services come from the rest of the customer's network. So we are just providing a switching part. And about the service delivery, the system is so that we have this equipment purchased using our own frame agreements, and it means that we are using the same device types that we are using in our own core and our own office network and our data centers. And it's also a similar case like SUNET is having, that we get better prices than the individual customers would have because of our volumes. And they don't need to run all this separate tender process. So that helps them a lot. And then we have a table where there is decided what is customer's responsibility and what is FUNET's responsibility. Like, for example, device installation, by default it's done by customer, but we can do it, but then there is an extra cost for it. And configuration management and monitoring, they are done by FUNET, and we are using the same NOC that we are using for our own FUNET core network, and same tools and processes. So all the alarm systems and ticketing systems and monitoring, they are same as what we are using in FUNET. And about configuration and monitoring, so everything what we are using in Juniper, it's automated. So we are using Ansible and Cena, and these are based on the tools that we developed for our FUNET 2020 core network migration. So it means that we have a very clean and standardized configuration in these new devices, and we can pre-configure these routers before we send them to a customer. So we just plug them in, and we can when we get management access, we can take care of everything else, and the configuration is stored in YAML files in Git repository, and routers and switches, also these Huawei's, we can add them to monitoring using Ansible during a provisioning. So we have the same tools as in the rest of the FUNET network. There are some examples, like we have these kind of router tables where we can see port status for every port, and then there is the one pilot geomap system, so we can see the link status and things like that on a geographical map. So this is actually the Helsinki University network here in this lower picture. And about the share management, we have a pilot with Helsinki University. So they have now all their core network traffic all the way down to the aggregation switches going over this FUNET campus network, and it means that it's a very, very large and very complex network. So there are a lot of changes and a lot of workload. If I have a look at the Git repository, it looks like there are more changes in that one network than all the rest of the campus customers we have combined. So it's a very big, and so that's why we wanted to have this shared management, and it means that customer can make their own configuration changes. So all configuration is managed by Ansible, like we do ourselves. And we have a customer-specific management server hosted by FUNET, where is this Git repository and all these YAML files and so on. And in this Helsinki University case, it has been so that almost all the configuration changes have been made by the customer. We made the initial configuration to have a connectivity between the devices, but after that, almost all the changes and all the traffic migrations were made by the customer using these tools and workflow that we are using. But then there has been a lot of this template development, especially for these switching functions, and also the consultation by FUNET for this migration design and planning and things like that. And they have completed this full migration by the end of August this year. So it took something like 8 months or something like that. And so we are now running everything over this new core. And what we have learned about so far is that these migration projects, they require expertise and a lot of design work, but they also give an opportunity to implement new functionality. So it means that there is not just that we take the old router and change the configuration so that it fits to our new templates and run it like before, but we usually do something extra there, like this campus interconnection or things like that. And about the share management part, we can say that it works when the customer has good enough skill in-house, and in the Helsinki University case that is true. So we have a very, very good team there working, so they adapted our workflow very quickly. But it means that also some of the smaller FUNET members maybe wouldn't be able to use a similar approach, so we have to do the configuration changes for them. And then for these smaller implementations like this one single switch, and those, we think that we should try to get customers to have redundant uplinks and redundant CPEs and or out of band management, because those are options currently. They are not required from a customer, because that makes things like software updates and those much more risky if you have just one device there and one link. And we still have a lot of that old equipment in old service, and it means that we have to plan how to encourage those customers to move to this new service, but also we have to think our own workload, because those migration projects take time, so we can take all the old customers at once. We have to somehow pick up which ones we want to do first and so on. And what we have notice in those migration projects that if there is some third party, like some subcontractor on customer side who we are not talking directly, it makes things usually much more complex and time consuming, because if we can agree things just with customer, it's much easier than if there is some third party, and especially in some cases because we are eating out their business, so we are not always very eager to get involved in these migrations, and that means that there has to be some kind of project management in these migrations also. It's not just that you take a new equipment to a customer and say that now everything starts to run. So, and we made a customer satisfaction measurement last spring for all the FUNET services, and for this campus service we got 3.7 on a 1 to 4 scale. So existing customers were pretty happy with this service. So I think that was all for me. So any questions?
Thank you, Asko. Thank you very much. Any questions? Yes, we have Jean Benoit. You want to ask your question? If not, I can read it. Is the provisioning system template Git repo centralized at FUNET or replicated on each site?
We have a centralized one everywhere else except this Helsinki University case. There we have a separate server, but it's on FUNET's network. But of course, you can always clone this Git repository to your own management server. But the master data is in this server that is hosted by FUNET.
Thank you. Any more questions? Okay, if you have questions, you can also wait till the end, and we will have all the three speakers answering your questions together. Thank you, Asko. And now our next speakers are Vidar Faltinsen and Morten Brekkebold. Vidar is head of the campus network department, responsible for a number of services, CNaaS being one of them. Other services included Roam, Zoom, VPN, and more. And he has been at UNINETT since 2004. And Morten Brekkebold is a senior software engineer working on developing network management open source software. Morten is the main developer of NAV. NAV is a network administration visualized, and it's a comprehensive open source network management tool widely used in Norway and elsewhere. Morten is also heading the development of the aggregated alert system Argus, which this talk is about. So, Vidar, if you want to share your screen.
Yeah. All right. I guess you can see the screen, right? Okay, thank you for the introduction. In Norway, we've worked with this CNaaS service for several years now, and we've had a small pilot customer for a while, but it's really this year that the service has gotten real, that we've officially launched it in June. And we have 2 large customers that we're working on. So I'll talk about that. We really believe that if this service is to scale, which is our ambition, it's key that we have good tools for proactive monitoring, NAV that Morten is working on, and other tools, and also tools for, of course, automating the configuration. And as David said, we're collaborating with SUNET on that, which is really good. So when we launched this service, we decided to offer several packages. So we can the full package is that we operate the entire campus network. That is the wireless and the wired. And the wired is the complete network, also access switches, so everything. But we could do Wi-Fi only or wired only, or we could do only the routers. Actually, the service with only the routers is just like in FUNET, I guess. It's been a service that we've had for several years, so we have quite a few customers there, typically smaller research institutes, smaller customers. In addition, I noticed there were some questions on that to David. We do offer it also for student accommodation. Also, I've heard questions about this. We include in the service more than the network itself. Of course, we offer the IPv6 and v4. We reuse address space. We offer a NAT4.4 service for those that need that. We offer a DHCP service. NTP, DNS firewall can be bundled into it. Edge-Roam, EduVPN can be bundled into it. And we can do management of access lists for the customer. So we worked on a service delivery model for the service. So we have service level agreement documents that we have in the contract with the customer. And really, what's really important, and I guess both SUNET and FUNET has touched upon that, is what should be done locally and what should be done centrally by UNINETT. And this I guess we learn as we go along how to do this best, but we see that it's key to really engage the local IT staff at the university or university college. And of course, there are some tasks that are really necessary for them to do the physical stuff, but we'd like to get them on board in various tasks in operating this. So this will we will tune this as we go along. Also, how we do operations. Also here we're learning as we're going along, but it's important that they have a local help desk that do the first line of support. And we need to clarify exactly what should be covered by that first line. Then it will escalate to our NOC, which is the NOC we use for the research network and other services, the common NOC we have at UNINETT. And in the end, it's the CNaaS experts, the third line. A couple of words about the payment model for the services. We do this slightly different, I guess, from SUNET and FUNET. We actually purchase all the equipment ourselves and own it and maintain it. And we offer the customer well, it's two models, but we can offer them a fixed yearly cost. So they do not have a large upfront cost to get an entire new network. We get a large upfront cost, but they don't. If they prefer to get an upfront cost, they can do it that way, and of course get a lower yearly cost. So it's two different models. I'll just briefly talk about this one large customer we've been working on since summer and are still working on, and this is a student accommodation at a larger university just south of Oslo. It will be, when it's completed, it will be 2,200 dormitories. And we are installing a complete new wired and wireless network. We're using Juniper in the wired network, and in this case, Aruba for the wireless. And we're installing an access point in every dormitory. So the students that are connected so far are really happy with the service. Our experience is that the students today have high expectations. They come to campus and to their dormitory with a lot of stuff that they want to get hooked on the network. And of course, we provide Edge-Roam, but it's not really easy to connect all the devices with Edge-Roam. So with the access point in each dormitory, we give them 1 gig wired connection, and we also give them a web-based self-service setup that they can set up their personal SSID to get all their gear hooked up. And this works really well. Okay, I won't take. The idea was that Morten will get the most time, so I will stop there and hand over to Morten so he can talk about the tools. Let's see, stop share.
Thank you, Ivar. Let's see. Okay, so I'm going to talk a little bit about our automation of CNaaS configuration, but mostly how we handle alerts from our CNaaS deployments. So, whereas SUNET's first generation deployment is based on Arista, ours is based on Juniper and Aruba. So our ultimate goal for automation is actually to use SUNET's CNaaS NMS software, which David mentioned earlier, to manage our CNaaS deployments. However, the time and resource constraints prevented us from actually adapting the CNaaS NMS software to our chosen vendor, and also from our differing network designs. So actually our network engineers, they have implemented our configuration management database in Excel, which if you have read the news lately, Excel is getting some flack for issues in the British health system. Our goal is still to implement CNaaS NMS, and so we are actually hiring more staff to work as developers on adapting CNaaS NMS to our needs. But as I said, we're doing Excel spreadsheets now for the configuration management, which means that we have all the equipment listed in Excel spreadsheets. Each switch has its own workbook or its own tab in the Excel workbook with the port configuration. And our Ansible tool chain is equipped to actually be populated from these spreadsheets to do the actual configuration. So the thing is that we also use zero-touch provisioning for bootstrapping devices that are connected to the network. And we use Ansible and PyEasy for configuration based on homegrown Jinja 2 templates. And we also have some magic for configuration LACP between switches as they appear in the network based on scanning LLDP neighbors in our switches. So this is basically our setup as of today. And this is, in my opinion, an interim setup. What about access port configuration? This is an issue for us because small local access port configuration changes, we allow those to be made by local IT staff using a tool in our NAV NMS tool. However, you can do things like changing the port descriptions, shut down ports, enable ports, switch the VLAN unless the VLAN is already selected by .1Q authentication. And we also have voice VLAN configuration possibilities. And all of this is supported by the port admin tool in NAV today. We've even added Juniper support since we are basing ourselves on Juniper on our first deployments. But our problem with this now is that now our configuration management database is not a single point of truth. And of course, this is another thing that the CNaaS NMS software will solve, as we have already partially written support for using the CNaaS NMS API directly from port admin to administer changes in switch port configuration from there. So hopefully we will start working on this in the near future. But the remainder of my talk will be about how we handle alerts. It's no surprise that our CNaaS deployment will use NAV for monitoring. NAV is an open source campus network monitoring tool with a 21-year-long history in the Norwegian higher education sector. It's developed by UNINETT, and we already provide customers with network management services based on NAV. So it's no surprise we're going with this. But NAV is not a multi-tenant system. So NAV is designed basically for one network at a time. So we want to give our customers access into the NAV installation to actually watch what's going on. But NAV is not suited for allowing multiple customers to access the same NAV installation and only see their part of the network. So the only way to go here is multiple installations of NAV, one per customer. And of course, this will get unwieldy pretty quickly in terms of configuring alerts and monitoring. So suddenly you will find yourself having to configure a alert profile in an entire suite of NAV installations. Also not good for our service center, which now needs to have like 10 monitors just to monitor the network. So our first idea was to how to handle this is to actually reuse NAV and sort of implement a super NAV. NAV already features an event and alert system with customizable notification profiles. And even on our other service platforms where we provide these tools to our customers, we have third-party tools that have been successfully integrated with the alert system of NAV. And so we thought, well, could we reuse this model for CNaaS and make a super NAV central where all the NAVs and our Zabbix service monitoring solutions, Nagios or whatever, can send all their alerts into a super NAV. But NAV was never really built to track incidents originating from systems outside of NAV itself. So this would not scale very well because all the alerts will be about objects that NAV knows nothing about. And of course, there is the tedious and complex issue of maintaining those pesky alert profiles in a bunch of different installations. So our next idea was to introduce something new. Why not write a new alert aggregation tool, which should be something that is completely agnostic of the source system's data models. And so we submitted this as a project proposal to the customer-driven project course at NTNU's Computer Science Department in 2019. And they chose this project and assigned it to a group of 6 students who wrote the first prototype of Argus according to our specifications last fall. Of course, we wanted to take this further, so we have been working on this this spring and the entire summer and are still working on it. So we are very close to releasing a version 1.0. So let me just explain a little about the architecture. The architecture of Argus is that we have an API which is implemented in Python. And at its core, this API is just a RESTful API over a database that stores incident information from multiple source systems. And each monitoring service instance is known as a source system in Argus. And each source system, such as, let's say we have NAV or we have multiple NAVs. At UNINETT, we have Zabbix for service monitoring. I know SUNET for a fact uses Nagios for service monitoring. And many people have many other systems as well. So these are source systems. Now to get alerts from NAV into the Argus API, we need a glue service. For NAV, this glue service can run in conjunction with the event engine of NAV and get a continuous stream of events, which the glue service translates into incidents and posts to the Argus API. And when incidents are resolved in NAV, this will also be synchronized into the Argus API. And so we will write the same thing for Zabbix, needs a separate glue service to translate between Zabbix and Argus, the same thing for Nagios. Then the second component of Argus is a user interface, which is implemented in React. So this is basically just a user interface acting as an API client. to show you the list of open incidents and to configure your notification profiles. In addition, we foresee the need to have some sort of API agents with knowledge from our configuration management database to actually go and make changes to incidents, tagging incidents with more information based on what is known from our other third-party systems. So this is a screenshot from the running installation of Argus. What do we need to know about an incident at the very least? Well, you need a description, you need a start time and end time for the incident, which system actually reported this incident. You need a link back to more details in the source system. So this, in this case, would link back to a nav page describing this event. We also want the option to have an arbitrary set of tags connected to an incident. So these tags are information from nav explaining what this, in more detail, what this is about. And these tags can be used for filtering in your notification profiles. So in this case, for example, if you are only interested in incidents concerning the room known as Tulin, then you would make a notification profile for this tag. And of course, very important for our service center and our NOC is to have the ability to connect a ticketing system here. So this incident is described in our ticketing system. There is, and of course, acknowledgments are also important here. Acknowledgments are a way to actually suppress active incidents from the list of incidents. So this is the list of active incidents. If you are currently working on something, maybe you created a ticket and you don't want this to be shown on the main list of open incidents, then you would add an acknowledgement. So an acknowledgement is just a sort of a message from someone that we are working on this, and it can also have an expiry time, so that if the incident has not been resolved within the expiry time, it will reappear in the list of active incidents. From this form, you can filter what is displayed here. You can use this to go and watch historic incidents, and you can filter on what source the incidents came from, or you can filter on tags. And of course, this supports federated login, currently through FEIDE, which is the national ID provider in Norway, but we expect to adapt this to other means later, such as GÉANT or Sweden's federated login system. Notification profiles. I see my time is running out here, so I'm going to skip over some of this, but you can configure notification profiles and have notifications sent via email and SMS. And we plan to add support for more mediums like Slack or Teams, which we use here at UNINETT. There is also a point that you might want to make relationships between incidents. So the model supports relations between incidents where you might say that these incidents have the same root cause, or these incidents are the same issue reported by two separate source systems. Or you could say that one of these issues is caused by the other. So these relations can be added manually or through the interface, but the interface does not support this, although the model does. So this will be need to added, and external agents can also go in and add these relationships based on knowledge from other systems, for example, on how your services are connected and so forth. So going forward, we will start testing version 1 next week in our NOC, which is important to get some real-world feedback. So NAV is already integrated. We have a glue service for NAV, and this is used on our 3 current CNaaS customers to ship incidents to the current Argus installation. We will shortly write glue services for other monitoring tools that we use here at UNINETT, such as Zabbix and Zeno. And I know SUNET are interested in integrating Nagios. So one of the things we will also focus on is to write a Python library for accessing the API so that this can be reused by all the glue services we write here at UNINETT. And so that's all I have for now. I'll leave you with some references to more information. Argus is, of course, open source. So the Argus repository at GitHub is the back-end system. And then we have the Argus front-end system in a separate repository. And if you're interested in more information about NAV, you can also find that at the URL at the bottom here. So thank you very much for your attention.
Thank you very much, Vidar and Morten. It looks like we have some questions from the audience now. We have Simon wanted to ask.
Yes, I was wondering about firewalls. Are these, because this is typically between our NREN backbones and the campus networks, and they seem to take a lot of effort acquiring and operating. So are they included in these CNaaS offerings at all?
Currently, we don't have an offering for operating firewalls. So, and in our use cases so far, there's actually not firewalls involved. It's routers with access lists. But but we are thinking about in the future to support firewalls somehow. But currently, we're not.
Okay,
So
I see.
it's also possible for the customer, if they have a firewall, they can operate it themselves, and we could integrate it into the, I mean, between the campus and the NREN network, as you say.
I thought that was kind of the normal case. I think our universities usually they have some kind of firewall, and it would be normally between our backbone and between the campus network. So,
yeah.
But you sound like this is would be the exception.
Well, in Norway, actually, it's different. Well, it varies. Some have firewalls, others depend on access or rely on access lists on routers.
Okay, cool. Thanks a lot.
Thank you, Vidar. Now we have Franz. If you want to ask your question.
I can unmute, thanks. I was wondering, the network configurations per institutions often differ. And if you offer services to student dorms, you may have requests like normal common things that support at homes, like DLNA, UPnP, for smart TVs and smart other stuff, Sonos, Chromecasts. Do you support that? And if so, can students then send a ticket if it's not functioning?
Well, I guess they can connect whatever they like in their dormitory, and but it's really up to them to get the stuff operating. And if they need help, they would get support from the local help desk at the university. I don't know if that answers your questions.
Does that mean that each student can make their own SSID?
Yes.
Ah.
That's because we operate the access point and manage it, but we have a system that they can. There's a application or web application that they can use where they can authorize, log in, and then set up their personal SSID for their dormitory. Yes.
Thanks for explaining that. And regarding other questions, how do you deal with wireless intrusions? So if there is a evil twin or some other bad stuff happening on the network, yeah, how do you detect it? And if it occurs, how do you act upon them?
Yeah, very good question. I'm sure we're going to have a lot of use cases. We're just starting up, and we are able to detect rogue APs, and but it's we really need a good collaboration with the local help desk so that they enforce it, so that so that they can, I mean, act if things like that happen. But yeah.
Okay, thanks.
Thank you. Sorry, Jeremy, I just skipped the question from Jeremy Sharp. You want
It's
to ask
okay.
it?
Yeah, thank you. Yeah, it's probably a question for all of the speakers, really. Just interested in having a flavour of the range of SLAs in place for the services, and how strict are they and how enforced are they?
I don't know who will answer that, but I think, well, again, it's early, you know, so they are, I would say that they are not so strict, and that we will adjust the service as we go along, that we agree with the customer what's a natural agreement of what they should do locally and what we should do centrally. But in terms of operations and what we commit to operating the core network 24/7 and the access part of the network during daytime. So, yeah. But maybe, yeah.
Okay, for FUNET path, it's so that those devices we are using, they have next business day support from vendors, but we don't have any strict SLAs. And also, if we have these kind of customers who have this just a single device that is single point of failure, we have informed them that it can take some days before we get it up and running again. Because if we get a device next business day and we have to configure it and send it to a customer who can be anywhere in Finland, so it takes some time.
Yeah, and SUNET, we also have a soft approach to it, so we don't actually promise any SLA in percent or so, but we, on the other hand, we forced the local campus to have replacement units locally. And everything is built redundantly, including the Wi-Fi coverage. So it's more or less just the access ports that could be affected.
Yeah, that's the same in Norway.
Yeah,
we have extra spares, edge switches and access points and redundant core.
Yeah, so we handle the hardware faults and warranty and issues like that in parallel with replacing it. So it's two processes yet to focus on getting them up and running again, and also handling the support request.
Okay, thank you. We had a pending question for you, David, from Liam. I don't know if Liam wants to ask it, or if not, I can read it. Okay, the question was, do you have standardized equipment vendor for switches and APs? Is this done by a framework drawdown?
Yeah, right now we did the procurement that Arista won fully. So both the core distribution and access points are all Arista right now, and that's an ongoing contract. So within a couple of years, we will do a new one, and we hope to keep each of these technology areas with one vendor. So possibly we swap the Wi-Fi gear to another vendor. So today, the totally recommended solution is pure Arista, but I know some brownfield areas that we will not make warranties for, but we will integrate with them. We also have support for Juniper, and we're working on Cisco as well. And since the NMS system is open, we encourage people to make these templates together with us, so we can support more or less all vendors.
Okay, thank you. If there are any questions from the audience for the speakers, now's your time. You can raise your hand, or you can just say something in the chat. If not, I will ask SUNET. David mentioned that you needed 2 developers full-time 1 year, and also 1 FTE more or less from your normal team. And for FUNET and for UNINETT, how many people have you dedicated to these efforts, to the CNaaS efforts?
For FUNET's part, I think it was in my presentation that we have 3 people, but not full-time. So we are working with core network as well.
Yes, and for UNINETT, we have, in terms of developing the tools that Morten talked about, we have 1.5 man year now, but we're increasing that to 2 man-years at least. And then on the service itself, we have 3 to 4 dedicated people working on the service.
Thank you. And any other questions? If not, I have also others. Well, and we have some ideas of how you started with this, but what were the reasons behind the decision of offering CNaaS services? Did your institutions come and was it something from the government? Was it something that it was from both sides? Did you decide to do it because you were bored of the amazing network you already had? Who wants to start?
Well, I could start, I guess. No, it's our customers, more and more our customers that would really like help with operating their network. They have too much to do, and would like help. So that's the reason for the service.
Yeah, SUNET is in the same situation, but also we've thought about being more service driven, since the networking and the fibers are becoming more and more a commodity. We want to stay relevant as an NREN as well.
Okay.
Yes, I think for FUNET's part, it's also it is a customer demand, and especially in these routing services, what we are mostly providing, because that's where we usually have more expertise than the customers.
Yeah, that's a point too. Another question would be, what would be your key advice for people or for NRENs that are starting offering these services? What was the challenge you faced that you think that you could avoid or that you could smooth somehow?
Yeah, I think it's to do it together with institutions is the best thing. That doing if they have trouble with keeping their staff, either they go into pension or either they lose them. I think to do it proactively, to do it together with them is the key thing. So, since it's very hard from a central point of view to do local work without any local knowledge.
Okay.
And also, I hope we can reuse some of the tools that we're developing, the work that's done with Ansible in FUNET and with CNaaS NMS in SUNET, and we're developing tools as you saw Morten presented. So you need a package of tools. So if this could be reused in other NRENs, it would be great.
Mm-hmm. Okay, we have another question from Franz. Do you want to unmute and ask it yourself, Franz?
Yes. I was wondering, you were saying as the local situation versus the global situations, and institutions often have their own policy regarding subnetting, which VLAN numbers they use. Some use them per building, per application, or other policies. So yeah, they are common to these policies. And how can you provide fast support if something happens, to know the situation of that local institutions and to understand what the problem is, without the need to read and understand a config or a policy or all the exceptions that you had made for this particular campus network?
It's a good question. I could try to answer on behalf of UNINETT. We with the customers we have so far, we adopt their local policy, and I mean their existing address space, their existing VLANs, and implement the same VLANs for the network when we operate it. And then we also provide, through the nav tool, we provide them a web-based interface so that they easily, without logging into the switches, can change the VLAN at any access port. So that means that a lot of the changes that's done locally, because a certain staff is moving to a new office or whatever, is easily dealt with locally, and it does not have to be dealt with our NOC. I don't know if it answers your question, but
Perhaps I misunderstand the service that you're offering on campus. Where if you allow people to change all network configurations, it's quite hard to provide support if something doesn't work anymore.
Yeah.
How do you deal with that?
Okay, so we don't, the local staff do not change the configuration on the devices, except they can use the management interface, as I explained. But besides that, we do all the configuration changes. So.
But you said you could assign VLANs within your NAV.
Yeah.
So
yeah.
that's if you make a mistake there.
Right. Yeah, but okay. If we make a mistake there, we have audit logs, so we know which user did the change, so we can see what has happened. So it's easy to track. I don't know if you want to add anything, Martin.
Just that these are just access ports, so they should not affect our infrastructure.
Okay,
For
thank you.
For our part, I could say that especially for these routers, because we have this Ansible, so it's very easy to read those configurations. We can get quite easily to the actual problem, and also all the underlying configuration is standard, so it helps. But then we have this thing like where we have this share management, like this Helsinki University, where they do 99% of all the changes, so we don't know much anymore what is going on there. But they have said that if they break something, they will fix it, and they usually can ask very detailed questions what might be missing in templates or something like that. And so it's more consulting for them, because they are taking responsibility of their own network.
Yeah, just to comment on getting the access through to the users. We are probably moving more to self-service for the users themselves to enroll devices and equipment. And I also see a ongoing problem with complexities and access lists, depending on if different campuses have different both network architecture and different firewall vendors and different sets and naming conventions. And I think in the end, we need some form of naming convention at least to be able to support these things. I think UNINETT, you do support the firewall as a service component, but SUNET has not really taking the local level that far. We just handle the core and distribution access point networks, not the actual data center usage.
Okay, we have like our last question. Liam is asking, sorry, how many extra support requests are these services generating to your NOC or service desk?
Yeah, I can start. It's a fairly during the first 5 production months, we actually just had 14 tickets that were specifically regarding these ones, and most ones were not faults. It was more configuration help ones. So it was very little. It was much less than expected for me, at least, which is good.
Yes. For UNINETT, for instance?
For us, it's really too early. We can give numbers at the next TNC.
Okay, for FUNET, Asko?
I would say that usually after we have got the migration complete, it usually comes down, and so there are not that many change requests and so on. And only if there is some new service coming into, so like we want to provide a new VPN or something like that. But usually it's stable after we have it up and running.
Okay. Thank you very much. The time is flying, and I see we're nearly approaching the end of the session. And just to wrap up, let me just show you one slide from, well, a couple of slides indeed. With this one is, the first one is about the the Cena service definition template we were working on last year, and that may help some NRENs that are starting offering these services. And UNINETT collaborated on it, and also Ordnet and FUNET have also worked on it. The idea here is that if you are starting offering the service and you need to sign an agreement with your institutions, you have kind of some guidelines or ideas to start with something before writing from scratch. And thank you very much, Asko and David and Morten and Vidar, for your interesting presentations. To wrap up, it seems like you're going to have a lot of work in the next years, and thanks to automation, it seems this is going to be quite easy for you. So this is also something that we need to think about from the NREN side. There are I hope this Infoshare was informative and was good for you. Thanks for attending it. And remember, we are also organizing other Infoshares in the next months. I have like another slide here to show this. It's we're having like an Infoshare on with Amon that is also useful for campus network management as a service if needed. We're going to have a telemetry workshop in November, and NMAS Infoshare also in November, an Infoshare on data transfer nodes in December, another one on orchestration, automation, and virtualization in December, and the quantum key distribution in January. Having said that, thank you very much for attending these presentations, and I hope you like it, and see you in the next one. Thank you.
Bye-bye. Thanks, everybody.